Jake Cho, and I'm an application engineer at Advantech USA. Today, I'm here to talk about the newly introduced technology for Advantech's SQF industrial SSDs. Kioxia has announced the successful development of its 8th generation 3D NAND flash memory technology known as BiCS8. BiCS8 is based on advanced 218-layer triple-level cell, or TLC technology. The new multi-layer technology has improved engineering process enhancements and significantly increased cell array density horizontally across the wafer. These lateral scaling advancements, in combination with 218 layers of vertical memory capability, enable BiCS8 not only to reduce power consumption, but also to offer more bits of storage capacity per wafer compared to the previous 112-layer BiCS5 technology, which helps to optimize cost. Besides, BiCS8 operates at 1600 MHz to offer up to 3600 mega transfers to match the upcoming high-speed throughput requirements of PCIe Gen5 systems. The production of BiCS8 in meaningful commercial volumes is expected to start in early 2026 and will be available in the maximum capacity of 2 terabytes per chip with the choice of either -25 to 85 degrees Celsius or -40 to 85 degrees Celsius operating temperature, making it possible to build up to 32 terabytes per SSD. This is a brief comparison of the current 5th generation BiCS5 NAND versus the 8th generation BiCS8. You can see that the maximum per chip density increases from 1 terabyte to 2 terabytes, which is a change that makes 32 gigabyte in 2.5-inch form factor or 8 terabyte in M.2 2280 SSD possible. NAND flash is unique because the storage controller writes and reads data at the page level, typically between 4 kilobytes and 16 kilobytes, and erases data at the block level of 64, 128, or 256 pages. Additionally, data is written to empty pages and cannot be overwritten as it can be with an HDD. So for example, when a user modifies a file stored in a flash SSD, the updated data is written to empty pages and the original pages are marked as invalid. Pages that contain invalid data cannot be reused until they're erased, so to reclaim the invalid pages, the controller must move the valid pages to another block, then the original block can be used to be erased and used for the new data. And when a new flash SSD has empty pages, writing data is a straightforward and efficient operation. As the drive fills up, the controller must move data and erase blocks before new data can be added. And this process of erasing and writing or programming data is referred to as the PE or program erase cycle. A flash memory device supports a limited number of PE cycles because each cycle causes a small amount of physical damage to the individual data cells. This damage occurs when electrons pass through a thin oxide layer that separates the cell substrate from the other cell components, such as the floating gate or charge trap layer. Repeated PE cycles cause the oxide layer to degrade, which results in an increasing number of bit errors until a block is no longer usable. So in short, you can consider the PE cycle of NAND as directly reflecting the service life of an SSD. Here you can see that BiCS8 maintains 3000 PE cycles, which is the same as BiCS5. So simply put, an SSD made with BiCS8 NAND can provide the same service life as the previous BiCS5-based SSD, but at a lower power consumption. Also, longevity is always an important consideration when choosing an SSD. People usually require 5 or more years to avoid frequent qualification and certification. So SSDs using BiCS8 can last until 2030 and beyond. Industrial applications need a drop-in replacement to maintain business continuity, reduce downtime, and control costs when the original product reaches the end of life. A drop-in replacement is a part or a component designed to be a direct substitute that requires minimal or no modification to the existing setup, allowing for a quick and seamless integration. This is crucial for avoiding the lengthy and costly process of replacing entire machines or redesigning systems. Advantech commits to drop-in replacement by launching an equivalent or better SSD approximately 2 years before the previous solution reaches the end of life. You can see from this chart that the new controller for the BiCS8 NAND is already available, and the design and validation of the new SSD is currently underway. This includes PS5031-E31 and PS5028-E28 for the NVMe SSD, and PS3117-S17 and PS3132-S32 for the SATA SSDs. These new SSDs will be formally released from Q4 2025 to Q2 2026. So for the BiCS8 SSD portfolio, we prepared two summary pages showing the corresponding solutions. This should give a clear view of which products are to use BiCS8. Just a quick reminder though, it's still uncertain whether all of these options will be moving forward, since this really depends on the future demand. Also, BiCS8 isn't designed to completely replace BiCS5. For smaller scale or niche applications, we'll continue to support BiCS5 solutions instead. Here's more detailed information of the cross-reference of new products versus the current BiCS5 SSDs. 2.5-inch SATA SSD from the 650F series for embedded applications will be launched by the end of 2025, and the performance-based 850F series will also be launching around the same time. M.2 2230, 2242, and 2280 for the 740F and 940F series will be released in the next 6 months, and M.2 2242 and 2280 solid solutions will be released in December 2025 and February 2026. This page looks at things from an industrial point of view, focusing on the key pain points and needs in data center and server applications. On the left side, you can see the 4 major challenges, and on the right, based on the BiCS8 advantages and solutions we talked about earlier, we've listed the recommended products that best fit these applications. This page looks at the topic from an industrial perspective, focusing on the main pain points and needs in embedded and industrial applications. On the left, we've listed 4 key challenges, and on the right, you can see the recommended products that match these use cases. This is the comparison of NVMe M.2 2280 SSD made with BiCS5 versus BiCS8. One thing to highlight here is HBM. HBM stands for Host Memory Buffer. This is a feature for DRAM-less SSDs that allows the SSD to borrow a small amount of your PC's RAM through direct memory access or DMA as a buffer to improve performance instead of having its own dedicated DRAM ICs. Another highlight is temperature rating. From BiCS8 SSDs, SQF will use a negative 25 to 85 degrees Celsius SKU to replace the current 0 to 70 degrees Celsius SKU. We will also keep the negative 40 to 85 degrees Celsius selection option. BiCS8 M.2 2280 SSDs will support PCIe Gen5 by 4 lanes, and their max power consumption is up to 6 watts, which is higher than the current 5.3 watts of Gen4 by 4 SSDs. If the doubled performance is not required, then we can downgrade Gen5 by 4 to Gen4 by 4 or Gen3 by 4 to reduce power consumption by around 30 to 40%. Here we have an application case that combines our SSD with the motherboard, and it's currently under a test. The main target is AI and RPA high-performance PCs, which are part of what's called Intelligent Process Automation, or IPA. These systems are designed to automate repetitive logic-based workflows, so they need powerful PCs that can provide and process data faster, analyze customer needs, and reduce system inefficiency. By using the SQF C8M740F series, we're able to deliver better performance, power efficiency, and higher capacity. Plus, its long-term supply helps customers avoid the hassle of reprogramming and requalifying when switching to new solutions later on. So in summary, the current 5th generation 112-layer BiCS5 SSD will last until the end of 2028, and the next 8th generation 218-layer BiCS8 SSD will last to 2030 and beyond. This includes our commitment to SATA SSDs, including 2.5-inch, M-SATA, M.2 2280, and 2242. The BiCS8 SSDs will start to roll out from the now to mid of 2026, so current users have good 2 years around to plan their product migration. With the exception of some of the very old form factors like the SATA Slim, all current SSDs will have a drop-in replacement available. The reliability of BiCS8 SSD is equivalent to that of the current BiCS5 SSDs, but the former with the new SSD controller will provide higher performance. Thank you for watching, and we appreciate your time and interest in SQF BiCS8.